Hello, let me introduce you some of the features of the new iOS Forensic Toolkit just released, version 8, Beta 2. You're probably familiar with the previous versions of iOS Forensic Toolkit, version 7 or earlier, and it had a text-like menu. And in next version, I hope that in release version of 8.0, we'll have a graphical user interface to make it simpler, but still this intermediate version, Beta 2, has another kind of user interface. You are going to do everything with commands. You have a main script called EIFT CMD or command, and you have to run it from the command line, of course, after you remove the quarantine flag from the folder where it is located. And when you run it without parameters, you see all the command line options. I will count them one by one. Agent is about installation and usage of our agent for agent type acquisition of the full file system and the keychain. Boot is to load the checkmate exploit and also perform file system acquisition and the checkrain acquisition, of course, also only for checkmate compatible devices. Info just gives the basic information about the device, whatever state it is in, whether it is in normal mode or in recovery mode or in DFU mode. SSH and SCP commands are a kind of, well, not they don't include any functionality right of the toolkit itself, but you can use it for your own purposes, for example, to download some file from the file system or upload some file to the file system, or anyway get the root access to the device after checkmate exploit is already used. JB command is to work with the jailbroken devices. Normal is for extended logical acquisition or to acquire the backup to get the files with the AFC or Apple File Conduit protocol and to get the diagnostic logs. RAMDisk is going to work only after loading the checkmate exploit. Serial is for debugging, if you have the debugging cable to understand what is going on between the computer and the actual device. And tools, some additional tools you probably won't use ever. Most of the features, well, all of the features are described in the product manual. I will only show you how to use the checkmate exploit to perform full file system and keychain acquisition of compatible devices. Compatible devices include iPhone 5S, iPhone 6, iPhone 6s with the Plus versions, and iPhone SE, first generation. It also supports some older models like iPhone 4 and iPhone 5. First of all, when working with the checkmate exploit, you have to boot the device into the DFU or device firmware update mode. It is quite simple if you know what to do. The instructions are also given in our manual and into the blog post. First, you have to connect the device to the computer. I have my one connected, and it is iPhone 5.6, running one of the latest version from iOS 14 generation. It is 14.8.1. You connect it to the computer using the USB-A cable. Never use USB-C connector if you are working with a MacBook that has only USB-C ports. So just use the connector USB-C to USB-A. And don't use USB hubs until you have a 6S or SE model and you're using the computer based on Apple Silicon. It is further explained in our blog post released recently. The exploit may fail if you connect the iPhone directly. Anyways, I have the Intel-based Mac and I have the iPhone 6s running iOS 14, and I have the phone connected, and now I press at the same time the power and home buttons for 8 seconds, and after 8 seconds I will release the power button and keep pressing only the home button. Let's try it. It will take 8 seconds. 1, 2, 3, 4, 5, 6, 7, 8. I release the power button and keep pressing the home button and show the iPhone in the recovery mode, and the screen of the iPhone is black. And now I can run the boot command. The boot command actually executes the checkmate exploit. Let's see how it goes. 3 stages, then again 3 stages. It doesn't always work from the first try. And it is first booted into pound-defu mode. When, well, everything worked, and now you can boot your own firmware, patched firmware that is not digitally signed. Anyway, what is needed at the current stage is the original firmware, exactly the same version that is running on the device. We have detected the version of the loader, actually not the iOS system, and it could be one of the following: 14.7 and all the way up to 14.8. If you don't know exactly what version is running on the device, if you don't know the passcode, for example, you can use any of those versions. I don't actually remember what version is running on this device, and so I can use any of the following. Most probably the version of the secure enclave firmware is the same. That means that it is going to work. In worst case, if the version is at least slightly different, device simply won't boot, but nothing on the user partition will be changed. So I drop the firmware there, right on the screen from the other window, where I have already downloaded several firmwares for different models and different versions. What the software actually does now, it unpacks the firmware, which is actually kind of zip files, and there are some components of the loader, and we split it into the different parts, patch everything dynamically. That's how we achieve the 100% compatibility with all the iOS versions available, starting from iOS 8.0 and all the way up to iOS 15.1. So we're extracting now. It takes some time, not more than just a few minutes. There could be another way to just have the firmware already patched and include it into our package, but first of all we can be sure that the firmware from one iOS version is going to work for the device running the other version. And the second problem is that it's not allowed, it's not actually legal to ship the Apple firmware any components with a third-party software. Well, actually some of forensic companies are doing that, and we selected the other way. It is much more complex, and it takes longer to load, and it still may fail under certain circumstances, but we have tested this stage on maybe some 4 dozen different devices running different versions. Yeah, now it's one of the latest stages. Yeah, everything is patched. The screen of the iPhone now shows booting logger, also as described in our blog post. Once everything is done, it will show exploited. Now the icon on the iPhone changed to exploited, and from now on we'll be able to connect to the RAMDisk, load it. RAMDisk is also custom. We'll also take it from the original firmware, add some components to it, like SSH. Yeah, okay, it is booted. So now we can interact with the RAMDisk. Let's run the command line and RAMDisk to see what options are available. Yeah, it's quite a lot of them. We can check mount to see what partitions are mounted. We can use load NFCD, which is quite important for some of the models and some of the OS versions. There's a separate command like sepboot, unlock data to unlock the disk, and also as described, first the most safe way is to run the load NFCD command first. RAMDisk load NFCD. It takes just a few seconds. It shows all the partitions. The structure of APFS partition is really complex. There are several ones. Most of them are not interesting for us and for forensic purposes. And we only work with the data partition, and that's the only one we're mounting it read-only to make sure that no changes will be made there. Well, okay. It says done. Until you see the error message, everything should be okay, and all the commands should be completed with done. Well, when you're doing the acquisition of the actual data, it can finish with the checksums MD5 and SHA1. So now we can unlock data. Don't worry if you don't understand some of the stages, and in the graphical user interface version we'll make it simpler and more obvious to use. But now just follow the instructions. Okay, now unlocking the data partition, also some operations, talking to the hypervisor, talking to secure enclave processor. Always feel a bit nervous when doing that, but anyway, okay, everything is okay. What we have to do now is to enter the device passcode, if it is set, of course. Now it is set. If we don't know the passcode, we can just press enter there, and the disk will be kind of partially unlocked. From now then, and you'll be able to access only files that are not encrypted, or the ones that are encrypted without usage of the device passcode, or only using the hardware keys. So we do know the passcode for this particular device. So we enter it, press enter. Yeah, data volume is unlocked. Let's check again what we can do with the RAM disk. Now the complete 100% contents of this device is available. The two commands you can or you should use now is passcode and the keychain. Keychain extract the complete keychain, all 100% of the records, in contrary with the acquisition of the keychain from password protected backups generated with iTunes or Finder on macOS, where some of the records remain locked. But here we can get the complete contents. For example, to get access to signal encrypted data. So we start RAMDisk, keychain, and we select the output file. We call it just keys XML. So we're now talking with our program, very small program, running on the RAM disk. Again, original operating system is not booted, and you can see all the keychain items have been decrypted. Some generic records, internet records, certificates, and encryption keys. About the same operation for acquiring the full file system. Let's tar is the command, and we set the output file name. the file will be created into the same folder where you run the toolkit from, or you can select the full path. This operation is actually simpler. We don't need any program to run on the RAMDisk. Just connect over SSH and we pull all the data from there using tar command. It's not a very fast process. We try to make it as fast as possible, but it seems that there are limitations on the USB controller, not the one that is on your computer obviously, but the one that is on that is used in the iPhone itself. It is a little bit faster in every newer model, and as far as I'm using iPhone 6s now, the speed is slightly over 30 megabytes per second, which gives us 2 gigabytes per minute, which is quite good. And most of the devices are being imaged in just 10-15 minutes or maybe half an hour. Okay, the data have been imaged, and it is 1.83 gigabytes, and we have two checksums, and we can check the, let's check it and run MD5. Let's check whether the checksum matches or not. Yeah, we get exactly the same value. If we never boot this device into the normal mode, into the native system running on this device, and will only boot into DFU or recovery mode, and in DFU mode use or not use our toolkit, but the main point is the booting, the boot mode. No files will be ever changed, and you will always get exactly the same result. So what to do now? The iPhone is running, it is booted from the RAMDisk, it is connected to the computer. If we'll just disconnect it, we won't be able to turn it off. It will just reboot, and this is actually bad, because we can enter it from there into the recovery mode, but that's a bad idea, because if you will miss just 1 or 2 seconds, device will boot into the normal mode, which will not be exactly forensically sound. So better to turn off the device, and when it is connected, the only way to do that is to run the halt command via SSH. Okay, doing that. Yeah, you cannot see it now because there is no indication what state is when the device is turned off, but the screen is now black and the device is completely turned off. What are you going to do next time if you want to get exactly the same result after disconnecting the iPhone from the computer? If you'll try to connect it to the computer, it will start to boot immediately. You cannot also connect it to the power source, and the best way is to put it into recovery mode. So just press the home button and then, only then, connect it to the computer. It will boot to recovery mode. That also doesn't change anything at all on the data partition, and you'll be absolutely safe. And that way, making sure that nothing is being changed in the data. I will not describe the other commands now, because again they're described in the user manual, and basically everything is about the same as you had in the version 7 and in beta 1. But for this particular acquisition method, checkmate, you just need to learn 4 or 5 commands, and they're described in our article on our company blog. Okay, thank you for listening.